Welcome back to my channel eGurukul and I am your host satishh.bhor. Hello friends, today we are going to talk about a problem based on the Modi method. Now we have discussed three methods in the transportation in the previous two lectures. अब इस lecture में हम बात करेंगे Modi method. Now see the first three methods, least cost method, northwest corner rule method and the WAM method basically gave us the initial feasible solution. Now initial feasible solution is the basic solution we obtain at the start of the problem, but then that may not be the best solution. That may not give me the lowest possible cost. How do I decide whether that solution is optimal or not? मुझे कैसे पता चलेगा कि मुझे जो वैम मेथड से सॉल्यूशन मिला है वो मेरा बेस्ट सॉल्यूशन है, वो मुझे सबसे कम कॉस्ट देगा? तो यहाँ पर पिक्चर में आ जाएगा एक नया मेथड जो इनिशियल फिजिबल सॉल्यूशन का optimality check करेगा. We are going to check whether the initial feasible solution we have obtained by the WAM method is optimal or not. So what I have done here is I have taken a problem, the same problem we had solved previously in the lecture number 2 by the WAM method, and I have even taken the solution. Now what I am going to do, I am going to simply check whether that solution is the best solution. Or else should I improve it? Can it be improved? Can I get some other solution which will be offer me a cost lower than this cost? So let's try to apply the method called as modified distribution method. हम यहाँ पे apply करेंगे modified distribution method, and in this method let's see what we are going to do. So here is my solution for the previous problem. This is the initial feasible solution we have obtained by the WAM method. Now before I start solving the problem by Modi method, let's try to understand how many cells we have got here. So we have got the cells here. Now there are some cells where we have made an allocation 1, 2, 3, 4, 5, 6. So my number of allocated cells are 6. Before I start the Modi method, I need to check one basic condition so that we are able to solve the problem by Modi method. And what is that condition? Let's see. My number of allocated cells. These allocated cells are also popularly called as occupied cells. That is the cells where I have made some allocation. So we have 1, 2, 3, 4, 5, 6 cells here. I will compare this with the number of rows and columns minus 1. My number of rows are A, B and C 3 factories. My number of columns are W1, W2, W3, W4, that is 4 warehouses. Minus 1, it will come to 6. And since this both match with each other, I can say my solution is not degenerate. Therefore, the solution is not degenerate. Now we need to understand what is degeneracy first of all. Now degeneracy is a situation where I am not able to apply the Modi method directly because the number of occupied cells or the allocated cells are not equal to number of rows plus columns minus 1, that is 6. अगर मेरा किसी भी प्रॉब्लम में नंबर ऑफ एलोकेटेड सेल्स और m+n-1 वाला कंडीशन इक्वल नहीं आया तो हम कहेंगे कि वो सॉल्यूशन डीजेनरेट है. एंड बाय डीजेनरेसी आई मीन टू से आई वोंट बी एबल टू सॉल्व द प्रॉब्लम डायरेक्टली बाय मोदी मेथड. I need to add something else called as epsilon, which I will discuss at a later stage in some other lecture. Right now, in this case, my problem is not degenerate, and we checked that by just comparing number of allocated cells with the number of rows plus columns minus 1. ये दोनों मैच हो गया, we are relieved, हमारा problem degenerate नहीं है, so I can go ahead with the Modi method. What I need to do in the Modi method? This was the first basic condition we checked. Now I will add two more variables, u and v. Here I will write u and here I will write v. Now this u and v are nothing but the dummies that are introduced by us just to check whether this is the best solution or not. And there is one basic condition that will be satisfied by this u and v, is that u plus v will be always equal to the cost at only the allocated cells. Means at allocated cells the cost will be equal to u plus v. So if I need to find out u, I can write c minus v. If I need to find out v, I can write c minus u. This is the basic formula I am going to use to calculate u and v first. Once we are done with u and v, then we are going to calculate something else for the unallocated cells. Now to get the values of u and v, I need to add an initial value which will be always 0 at the first row. I can add this 0 anywhere, I can take any number on this earth, but taking a 0 will simplify the thing. Now using this 0, I will calculate all the other values of u and v, and the formulas are quite simple. To get the value of v, we have c minus u. To get the values of u, we have c minus v. So let's try to calculate u and v. So here I have a 0 first. In my first row there is only one occupied cell, that is 26. How much is the cost here? 26 minus 0. So if I cost minus u will give me the corresponding v. अगर मैं cost में से u minus करता हूँ, c minus u मुझे क्या मिलेगा? v मिलेगा. So in this case it will be 26 minus 0, it will be 26. I am writing in the bracket just for your reference how we got this u and v. The next step will be, from this 0 I got the value 26 here. Now I will go in this particular column and I will try to check for the any other occupied cells. I have got one more occupied cell here which has a cost of 46. So 46 minus 26, I can get a 20 here. So 46 minus 26, I got 20 here. So एक 0 से हमको 26 मिला. ये कॉलम में यहाँ पर ऑक्युपाइड सेल था, तो 46 minus 26 is 20. Now I'll go in this particular row. In this particular row we have two more occupied cells. So 36 minus 20, it will be 16, and 34 minus 20, it will be 14. So I'm using only the occupied cells. Try to get this basics very clear of calculating u and v. That is the only challenge I personally feel in the Modi method for a student. For a new student, this is the most important, the basic step. Once you are done with u and v, I think then you are quite comfortable with the remaining problem. We have got first 0, then we got a 26, then we got the 20, and from 20 we got these two values. Now I need one more value here and here. In this cell we have these two occupied cells. I got 54 here. 54 minus 16, I can get the corresponding u. So 54 minus 16, I can write 38. And then we have one more here, this one, in which the occupied cell is 36. So 36 minus 38, it will be minus 2. So I am done with all the values of u and v. And now I will jump on the unallocated cells, that is the unoccupied cells. For unoccupied cells, we are going to use a formula to calculate the delta value, which will be the indicator whether this is the best solution or not. Now the delta value for unoccupied cell will be delta equals to cost minus u plus v. This we calculate just for the sake of finding out whether my given solution is optimal or not. Now let us calculate the delta values for unoccupied cells, and I will write those delta values in the bottom right side of the unallocated cells. अनएलोकेटेड सेल के बॉटम राइट में हम लोग लिखेंगे डेल्टा वैल्यूज. इन द फर्स्ट स्टेज this is my unoccupied cell. My corresponding u is 0 and the corresponding v is 14. So 0 plus 14 will be 14 and 42 minus 14 will be 28. Next, this is unoccupied cell. Corresponding u is 0 and the corresponding v is 16. So 0 plus 16 will be 16 and 32 minus 16 will be 16. In my next cell, my u is 0 and the corresponding v is minus 2. So 0 plus minus 2 will be minus 2 and 50 minus minus 2 will be 52. My next unoccupied cell in the second row is 28. So here my corresponding u is 20 and the corresponding v is minus 2. So 20 plus minus 2 is 18 and 28 minus 18, that is cost minus u plus v will be 10. We have a 64 here. Corresponding u is 38 and corresponding v is 14. So 38 plus 14 will be 52 and 64 minus 52 will be 12. 38 plus 26 comes to 64 and 82 minus 64 will be 18. So we have obtained all the delta values 28, 16, 54, 10, 12 and 18, and these delta values are not negative, which is an indicator that this is my optimal solution. So we can conclude, since delta values are not negative, solution is optimal. If the delta value of any of the unoccupied cell or the unallocated cell was negative, that is an indicator that by not making an allocation in that particular cell you are suffering a loss, आपका cost increase हो रहा है. अगर delta value negative आता था तो हम कहते थे कि भाई ये solution best solution नहीं है, हम इससे भी cost कम कर सकते हैं. But because in this case there is no negative value, I can conclude that the delta values are not negative and therefore the solution is optimal. And after this stage we are going to obtain the final solution. Since there is no change in the solution, I will just write the final answer of the previous problem, lecture number 2. So the total cost of transportation will remain same, that is rupees 1592. How I obtain 1592? Exactly the same in the previous lecture. 6 into 34, 3 into 36, 11 into 26, 4 into 46 plus 12 into 36 plus 7 into 54. हमने इन करस्पॉन्डिंग एलोकेटेड सेल्स का एलोकेशन को करस्पॉन्डिंग कॉस्ट से मल्टीप्लाई किया और उसका टोटल किया and I got the final answer. I have written it directly as I had done it in the previous problem. I hope you got the whole concept of Modi method very clear. This has been the first problem. I will solve one or two more problems. There will be one more problem on degeneracy where we will actually see how to solve a degenerate problem. Thanks for watching this video. Do subscribe to our channel.